Question 1. Analysis of process optimization within a VMware NSX X environment governed by a specific regulatory framework that mandates strict data protection and network segmentation presents a critical challenge. Which of the following approaches best balances the need for improved network performance with the imperative to maintain regulatory compliance and security posture? Option A. Disabling certain NSX security features, such as micro-segmentation policies, in high-traffic zones to reduce processing overhead and improve packet forwarding rates. Option B. Upgrading all underlying physical network hardware to the latest specifications, assuming that hardware limitations are the primary cause of performance degradation. Option C. Deploying custom, undocumented scripts to automate NSX policy changes for performance tuning without formal review or testing. Option D. Implementing NSX distributed firewall rules that dynamically adjust based on real-time traffic analysis and application profiles to optimize traffic flow between segmented workloads. The correct answer is D. Implementing NSX distributed firewall rules that dynamically adjust based on real-time traffic analysis and application profiles to optimize traffic flow between segmented workloads. Explanation. The scenario presents a common challenge in network operations, optimizing the performance of a VMware NSX X environment without compromising security or compliance. The professional must balance the need for efficiency with the strict requirements of the regulatory framework governing their operations. This requires a deep understanding of NSX capabilities, potential performance bottlenecks, and the specific compliance mandates in place. The challenge lies in identifying solutions that are both technically sound and legally defensible, ensuring that any optimization efforts do not inadvertently create vulnerabilities or violate established protocols. The correct approach focuses on leveraging NSX's native features for process optimization, specifically through intelligent workload placement and resource allocation. This aligns with best professional practices by utilizing the platform's design capabilities to achieve efficiency gains. By analyzing traffic patterns and application requirements, administrators can dynamically adjust network policies and resource assignments. This proactive and data-driven method ensures that optimization is targeted and effective, minimizing disruption and maximizing performance. Furthermore, this approach is inherently compliant as it operates within the intended functionality of the NSX platform and adheres to the established security posture. An incorrect approach that involves disabling security features to improve performance is a significant regulatory and ethical failure. This directly violates the principle of least privilege and the fundamental security requirements mandated by most regulatory frameworks. Such an action would expose the network to unacceptable risks, potentially leading to data breaches, unauthorized access, and severe compliance penalties. Another incorrect approach, such as implementing custom, undocumented scripts for optimization without rigorous testing and validation, poses a substantial risk. This bypasses established change management processes and introduces an unknown variable into the network's security and operational integrity. It is a failure to adhere to documented procedures and a disregard for the potential for unintended consequences, which can lead to compliance violations and operational instability. A third incorrect approach, focusing solely on hardware upgrades without a thorough analysis of the NSX configuration, ignores the software-defined nature of the solution. This is inefficient and potentially wasteful, as performance issues are often rooted in configuration or policy rather than raw hardware capacity. It also fails to address the underlying architectural reasons for performance degradation, leading to a superficial fix. Professional decision-making in such situations requires a systematic approach. First, thoroughly understand the specific regulatory requirements and compliance mandates applicable to the environment. Second, conduct a comprehensive analysis of the current NSX configuration, traffic flows, and performance metrics. Third, identify potential optimization strategies that align with NSX best practices and the organization's security policies. Fourth, evaluate the risks and benefits of each proposed solution, prioritizing those that enhance performance without compromising security or compliance. Finally, implement changes through a controlled process, including thorough testing, documentation, and rollback plans, ensuring that all actions are auditable and defensible. Question 2. Stakeholder feedback indicates that users are experiencing intermittent network latency and packet loss within the virtualized environment, impacting application performance. The IT operations team suspects a bottleneck within the VMware NSX deployment. What is the most professional and effective approach to diagnose and resolve this issue? Option A. Immediately begin reconfiguring NSX edge firewall rules and NAT policies, as these are common sources of latency, and monitor for improvements. Option B. Initiate a phased investigation, starting with reviewing NSX manager logs, correlating with vSphere host performance metrics, and then examining NSX edge and distributed firewall rule performance, utilizing NSX's built-in diagnostic tools to identify the root cause before implementing any changes. Option C. Rely primarily on the qualitative descriptions of latency provided by stakeholders to guide the troubleshooting process and make configuration adjustments based on their perceived impact. Option D. Focus solely on analyzing the performance of the NSX distributed firewall on the affected virtual machines, assuming the issue is isolated to their network configurations. The correct answer is B. Initiate a phased investigation, starting with reviewing NSX manager logs, correlating with vSphere host performance metrics, and then examining NSX edge and distributed firewall rule performance, utilizing NSX's built-in diagnostic tools to identify the root cause before implementing any changes. Explanation: scenario analysis. This scenario presents a common challenge in IT operation where performance bottlenecks are impacting user experience and business processes. The challenge lies in identifying the root cause of the performance degradation within a complex, multi-layered NSX environment without disrupting ongoing operations or introducing new risks. Stakeholder feedback, while valuable, can be subjective and requires objective validation. The professional must balance the urgency of resolving the issue with the need for a systematic, evidence-based approach that adheres to best practices and potential regulatory compliance requirements related to service availability and data integrity. Correct approach analysis. The correct approach involves a structured, phased investigation that prioritizes non-disruptive data collection and analysis. This aligns with the principle of minimizing operational impact, a key tenet in IT service management frameworks, and often implicitly or explicitly required by regulations governing business continuity and disaster recovery. By starting with high-level monitoring and progressively drilling down into specific NSX components, e.g., NSX manager, edge nodes, host transport nodes, distributed firewall rules, the professional can efficiently isolate the problem area. Utilizing NSX's built-in diagnostic tools and logs, coupled with correlation against infrastructure metrics, provides the necessary evidence to pinpoint the root cause. This methodical approach ensures that any proposed remediation is well-informed and less likely to cause unintended consequences, thereby upholding service-level agreements and regulatory obligations for system stability. Incorrect approach is analysis, an approach that immediately involves making configuration changes without thorough investigation is professionally unacceptable. This violates the principle of change management and introduces significant risk. Such actions could lead to further performance degradation, service outages, or security vulnerabilities, directly contravening regulatory expectations for system stability and data protection. Demonstrates a lack of due diligence and a failure to apply a systematic problem-solving methodology. Another incorrect approach would be to solely rely on anecdotal stakeholder feedback without independent verification. While feedback is important, it is not a substitute for technical investigation. Basing remediation solely on subjective input can lead to misdiagnosis and wasted effort, potentially delaying the resolution of the actual issue. This can have regulatory implications if it leads to prolonged service disruption, impacting compliance with service-level agreements or data availability mandates. Focusing exclusively on one NSX component without considering its interactions with other parts of the network or the underlying infrastructure is also a flawed strategy. NSX is an integrated solution, and performance issues often stem from interdependencies. A siloed investigation risks missing the true root cause, leading to ineffective or even detrimental remediation efforts. This can indirectly impact regulatory compliance by failing to maintain the expected level of service availability and security. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This typically involves 1. Problem identification and scoping. Clearly define the reported issue and its impact. 2. Information gathering. Collect relevant data from all potential sources, including monitoring tools, logs, and stakeholder input. 3. Hypothesis generation. Formulate potential causes based on the gathered information. 4. Testing and validation. Systematically test hypotheses using diagnostic tools and controlled experiments. 5. Root cause analysis. Identify the definitive cause of the problem. 6. Solution design and implementation. Develop and apply a targeted solution. 7. Verification and monitoring. Confirm the issue is resolved and monitor for recurrence. This systematic approach ensures that decisions are data-driven, risks are managed, and regulatory and ethical obligations are met. Question 3. Risk assessment procedures indicate that network traffic processing within the VMware NSX environment is experiencing increased latency, potentially impacting application performance and availability. To address this, which of the following approaches best optimizes the processing of distributed firewall rules for enhanced efficiency? Option A. Creating an exhaustive list of highly granular, individual firewall rules for every conceivable traffic permutation. Option B. Implementing security policies by adding rules sequentially as new traffic flows are identified, without regard to rule order. Option C. Disabling specific distributed firewall rule processing features to reduce the computational load on hypervisors. Option D. Strategically ordering distributed firewall rules based on frequency of match and specificity, and utilizing security groups for efficient object management. Correct answer is D. Strategically ordering distributed firewall rules based on frequency of match and specificity, and utilizing security groups for efficient object management. Explanation. Scenario analysis. This scenario presents a challenge in optimizing network traffic flow within a VMware NSX environment, specifically concerning the efficient processing of security policies. The core difficulty lies in balancing the need for granular security enforcement with the imperative to minimize latency and resource overhead. Misconfiguration or suboptimal design can lead to performance degradation, increased operational costs, and potentially impact application availability, all of which carry significant business and compliance implications. The professional must navigate the technical complexities of NSX policy application while adhering to best practices for process optimization. Correct approach analysis. The correct approach involves leveraging NSX's inherent capabilities for policy optimization, such as distributed firewall rule ordering and the use of security groups. By strategically placing more frequently matched or broader rules higher in the rule set, and utilizing efficient object grouping, the system can process traffic more rapidly. This minimizes the number of rules that need to be evaluated for each packet, thereby reducing CPU load on hypervisors and network infrastructure. This aligns with the principle of least privilege and efficient resource utilization, which are foundational to robust and cost-effective IT operations. From a regulatory perspective, efficient processing contributes to maintaining service levels and can indirectly support compliance with availability and performance mandates by preventing bottlenecks. Incorrect approaches analysis. One incorrect approach is to implement security policies in a purely sequential additive manner without considering the order of evaluation. This can lead to a situation where less specific or infrequently used rules are evaluated before more critical, frequently matched rules, increasing processing time and latency. This is a failure of process optimization and can lead to performance issues that might indirectly impact compliance with service-level agreements, SLAs. Another incorrect approach is to create a large number of highly specific, individual firewall rules for every possible traffic flow without utilizing security groups or logical constructs. While seemingly thorough, this approach overwhelms the NSX policy engine, leading to significant processing overhead and slow rule evaluation. This lack of abstraction and aggregation is inefficient and counterproductive to optimization goals. A third incorrect approach is to disable or bypass certain security policy processing mechanisms in an attempt to gain performance, without a thorough understanding of the security implications or a documented exception process. This introduces significant security risks and is a direct violation of security best practices and potentially regulatory requirements for maintaining a secure posture. Such actions would likely be considered a failure of due diligence and risk management. Professional reasoning. professionals should approach NSX policy optimization by first understanding the traffic patterns and security requirements. This involves analyzing existing network flows and identifying critical applications and their communication needs. The next step is to design policies that are both secure and efficient, prioritizing the use of NSX features like security groups, tags, and logical constructs to simplify rule management and improve processing performance. Regular review and refinement of policies are essential to adapt to changing network conditions and security threats. When considering any deviation from standard optimization techniques, a formal risk assessment and documented justification are paramount, ensuring that any trade-offs are understood and accepted at an appropriate level. Question 4. Research into the integration of advanced NSX4X security features for enhanced microsegmentation and threat detection. A key stakeholder group is advocating for rapid deployment to capitalize on perceived operational efficiencies and cost reductions. What is the most professionally responsible approach to evaluating and potentially adopting these new features? Option A. Prioritize immediate deployment to realize cost savings, with a plan to address security and compliance concerns retrospectively if issues arise. Option B. Proceed with deployment based on the vendor's claims of enhanced security and operational benefits, assuming existing security infrastructure will adequately cover the new features. Option C. Rely solely on the recommendations of the NSX vendors, technical documentation, and sales representatives for validation of security and compliance aspects. Option D. Initiate a comprehensive security and compliance review involving relevant teams to assess the features against organizational policies and regulatory mandates before any deployment. The correct answer is D. Initiate a comprehensive security and compliance review involving relevant teams to assess the features against organizational policies and regulatory mandates before any deployment. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between rapid technological adoption and the need for robust security and compliance. Stakeholders, particularly those focused on business agility and cost reduction, may prioritize speed and functionality over comprehensive security validation. The challenge lies in balancing these competing interests while ensuring that the deployment of new NSX features aligns with established security policies and regulatory mandates, which are paramount in a professional IT environment. The risk of introducing vulnerabilities or non-compliance through untested or inadequately configured features necessitates a structured and informed approach. Correct approach analysis. The correct approach involves a proactive engagement with security and compliance teams early in the evaluation process. This ensures that potential security implications and regulatory adherence are assessed asterisk before asterisk. A decision is made to adopt new NSX features. This aligns with best professional practice by embedding security and compliance into the technology lifecycle, rather than treating them as an afterthought. From a regulatory perspective, this approach demonstrates due diligence and a commitment to maintaining a secure and compliant infrastructure, which is often a requirement for industry-specific regulations and general data protection laws. It fosters a culture of security by design and ensures that business objectives are met without compromising the organization's security posture or legal standing. Incorrect approach is analysis. Adopting new NSX features based solely on perceived cost savings or immediate operational benefits without a thorough security and compliance review represents a significant regulatory and ethical failure. This approach prioritizes short-term gains over long-term risk management, potentially exposing the organization to data breaches, regulatory fines, and reputational damage. It violates the principle of responsible technology deployment, which mandates that security and compliance be integral to any IT decision. Implementing new NSX features based on vendor recommendations alone, without independent validation against organizational policies and regulatory requirements, is also professionally unacceptable. While vendor guidance is valuable, it cannot substitute for an organization's own risk assessment and compliance obligations. This approach abdicates responsibility for security and compliance, creating a potential gap that could be exploited by threats or lead to non-compliance. Relying on the assumption that existing security controls will automatically cover new NSX features is a dangerous oversight. Each new feature or configuration change can introduce unique attack vectors or compliance challenges. This assumption demonstrates a lack of proactive risk assessment and a failure to adapt security measures to evolving technology, which is a direct contravention of professional security and compliance standards. Professional reasoning. Professionals should adopt a risk-based decision-making framework. This involves identifying potential risks associated with new technology adoption, assessing their likelihood and impact, and implementing appropriate mitigation strategies. Early and continuous engagement with security, compliance, and legal teams is crucial. This ensures that all relevant perspectives are considered and that decisions are informed by a comprehensive understanding of the organization's security posture and regulatory landscape. A structured evaluation process, including pilot testing, security reviews, and compliance checks, should be a mandatory step before full-scale deployment. Question 5. Cost-benefit analysis shows that implementing VMware NSX microsegmentation offers significant security enhancements, but the initial investment and operational complexity are substantial. Which approach best justifies proceeding with this initiative from a strategic stakeholder perspective? Option A. Proceed with a full, immediate deployment of NSX microsegmentation to achieve maximum security benefits, assuming that operational challenges will be resolved through ad hoc adjustments and future resource allocation. Option B. Prioritize the implementation of NSX microsegmentation based on the projected reduction in the likelihood and impact of security breaches, while developing a phased rollout plan to manage operational complexity and training requirements. Option C. Defer the implementation of NSX microsegmentation until a more compelling business case can be developed, focusing on immediate, lower-cost security measures to address current vulnerabilities. Option D. Focus the cost-benefit analysis solely on the capital expenditure for NSX licenses and hardware, as this represents the most significant and quantifiable cost, and assume operational benefits will naturally follow. The correct answer is B. Prioritize the implementation of NSX microsegmentation based on the projected reduction in the likelihood and impact of security breaches, while developing a phased rollout plan to manage operational complexity and training requirements. Explanation. This scenario presents a common challenge in network security architecture, balancing the immediate need for enhanced security with the long-term operational and financial implications of implementing a new technology. The professional challenge lies in translating a technical solution, NSX microsegmentation, into a business case that resonates with various stakeholders, each with different priorities and risk appetites. The requirement to adhere strictly to the VMware NSX4X Professional V2 exam's regulatory framework means that any proposed solution must align with established best practices for network security and compliance within that context, even if specific external regulations are not explicitly detailed in the exam syllabus. The correct approach emphasizes a comprehensive evaluation that goes beyond mere technical feasibility. It involves a thorough cost-benefit analysis that considers not only direct implementation costs, but also the potential reduction in security incidents, the cost of breaches, operational efficiencies gained through automation, and the alignment with potential future compliance mandates that might be influenced by industry trends and vendor roadmaps. This holistic view ensures that the investment in NSX microsegmentation is justified from multiple perspectives, including IT operations, security, and finance. It represents best professional practice by demonstrating due diligence, strategic thinking, and a commitment to maximizing return on investment while mitigating risk. The justification is rooted in the principle of informed decision-making, where technical proposals are validated against business objectives and potential impacts. Incorrect approaches fail by neglecting critical aspects of the decision-making process or by misinterpreting the scope of the analysis. Focusing solely on the initial capital expenditure without considering the total cost of ownership, including ongoing licensing, training, and support, leads to an incomplete financial picture. Similarly, prioritizing immediate security gains without assessing the operational overhead or the potential for disruption during implementation overlooks the practical realities of deploying new infrastructure. A failure to engage with key stakeholders, such as finance and operations teams, to understand their concerns and requirements results in a solution that may be technically sound, but operationally unviable or financially unsupported. These failures represent regulatory or ethical lapses because they can lead to misallocation of resources, increased organizational risk due to inadequate security, and a lack of transparency in the decision-making process, potentially violating principles of responsible technology adoption and governance. Professional reasoning process for such situations should involve a structured approach. 1. Define the problem and the desired outcomes clearly. 2. Identify all relevant stakeholders and their perspectives. 3. Conduct a thorough technical assessment of potential solutions. 4. Perform a comprehensive cost-benefit analysis, including both tangible and intangible factors. 5. Evaluate risks and mitigation strategies associated with each option. 6. Develop a clear communication plan to present findings and recommendations to stakeholders. 7. Seek consensus and approval based on a well-supported business case. Question 6. The risk matrix shows a high likelihood of a security breach due to an unpatched vulnerability in a critical NSX component, with a moderate impact on business operations. Which of the following actions best addresses this situation while adhering to professional security and operational best practices? Option A. Apply the patch immediately to all affected NSX components without prior testing to eliminate the security risk as quickly as possible. Option B. Implement a temporary network segmentation workaround to isolate the vulnerable component and accept the residual risk until a permanent solution can be identified. Option C. Implement a comprehensive patch management strategy that includes thorough testing in a staging environment, phased rollout to production, and clear rollback procedures, while communicating the plan and potential risks to all affected stakeholders. Option D. Defer patching the vulnerability until the next scheduled maintenance window to avoid any potential disruption to current business operations. Correct answer is C. Implement a comprehensive patch management strategy that includes thorough testing in a staging environment, phased rollout to production, and clear rollback procedures, while communicating the plan and potential risks to all affected stakeholders. Explanation. The risk matrix shows a high likelihood of a security breach due to an unpatched vulnerability in a critical NSX component, with a moderate impact on business operations. This scenario is professionally challenging because it requires balancing immediate operational needs with long-term security posture and compliance requirements. The pressure to maintain service availability can conflict with the imperative to implement security patches, especially if the patching process is perceived as disruptive. Careful judgment is required to assess the true risk, the effectiveness of mitigation strategies, and the potential consequences of inaction, all within the context of regulatory obligations. Correct approach represents best professional practice because it prioritizes a proactive and documented risk management process aligned with industry standards and potential regulatory scrutiny. By engaging stakeholders, performing a thorough risk assessment, and developing a phased remediation plan that includes testing and rollback procedures, the organization demonstrates due diligence. This approach ensures that security decisions are informed, justifiable, and auditable, minimizing the likelihood of regulatory noncompliance and reputational damage. It reflects a commitment to maintaining a secure and resilient network infrastructure. An incorrect approach that involves ignoring the vulnerability due to perceived operational impact is professionally unacceptable. This constitutes a failure to adhere to basic security principles and potentially violates regulatory frameworks that mandate the protection of sensitive data and systems. Such inaction creates a significant liability and exposes the organization to severe consequences, including financial penalties, legal action, and loss of customer trust. It demonstrates a disregard for risk management and a lack of professional responsibility. Another incorrect approach, such as applying a temporary workaround without a clear plan for permanent remediation, is also professionally unsound. While it might offer short-term relief, it leaves the underlying vulnerability unaddressed, creating a persistent risk. This can be viewed as a failure to implement effective controls and may not satisfy regulatory requirements for ongoing security management. It suggests a reactive rather than a strategic approach to security, which is unsustainable and prone to future failures. A third incorrect approach, applying the patch without proper testing or stakeholder communication, risks causing unintended service disruptions. While seemingly decisive, this can lead to operational chaos, data loss, and significant business impact, potentially outweighing the initial security risk. This demonstrates a lack of understanding of change management best practices and the interconnectedness of network components, leading to a failure in professional execution and potentially violating service-level agreements or compliance mandates related to service continuity. The professional reasoning process for similar situations should involve a structured risk assessment framework. This includes identifying assets, threats, and vulnerabilities, analyzing the likelihood and impact of potential incidents, evaluating existing controls, and determining appropriate mitigation strategies. Crucially, it requires clear communication and collaboration with all relevant stakeholders, including IT operations, security teams, legal, and business units. Decisions should be documented, and remediation plans should be phased, tested, and monitored, with clear rollback procedures in place. This systematic approach ensures that security measures are effective, proportionate, and aligned with business objectives and regulatory obligations. Question 7. Which approach would be most appropriate for a network security professional tasked with resolving performance degradation impacting a critical business application, where initial observations suggest a potential conflict with NSX security policies? Option A. Immediately disable all NSX security policies related to the affected application to restore performance, while a full investigation is conducted later. Option B. Escalate the issue directly to senior management with a recommendation to bypass NSX security for the application until a solution can be found. Option C. Conduct a detailed analysis of NSX firewall logs and traffic flows to pinpoint specific security rules causing the performance bottleneck, and then propose and test targeted policy optimizations. Option D. Implement overly permissive firewall rules for the application's traffic to eliminate any potential security policy conflicts, prioritizing application availability. Correct answer is C. Conduct a detailed analysis of NSX firewall logs and traffic flows to pinpoint specific security rules causing the performance bottleneck, and then propose and test targeted policy optimizations. Explanation. Scenario analysis. This scenario presents a common challenge in network security architecture, where a critical business application's performance is being impacted by security policy enforcement. The challenge lies in balancing the imperative of robust security with the operational necessity of application availability and performance. A hasty decision could either compromise security posture or lead to significant business disruption, both of which have serious implications. The professional must navigate technical complexities, understand business impact, and adhere to established security principles and potential regulatory compliance requirements related to data protection and service availability. Correct approach analysis. The correct approach involves a systematic data-driven investigation to identify the root cause of the performance degradation. This includes analyzing NSX firewall logs, application traffic patterns, and the specific security rules being applied. The goal is to determine if the security policy is indeed the bottleneck, and if so, to identify the precise rule causing the issue. Once identified, the professional should propose and test specific, targeted modifications to the security policy. This might involve optimizing rule order, refining match criteria, or implementing more efficient security services. This approach represents best professional practice because it prioritizes a thorough understanding of the problem before implementing solutions, minimizing the risk of unintended consequences. It aligns with principles of least privilege and defense in depth by ensuring security measures are effective without being overly restrictive. Adherence to change management processes and thorough testing before production deployment are crucial to prevent further disruption and maintain compliance with any service-level agreements, SLAs, or regulatory mandates concerning application uptime and data integrity. Incorrect approaches analysis. Disabling security policies indiscriminately is a significant regulatory and ethical failure. It directly undermines the organization's security posture, potentially exposing sensitive data to unauthorized access or modification, which could violate data protection regulations, e.g., GDPR, CCPA if applicable to the jurisdiction. It also demonstrates a lack of professional responsibility by prioritizing expediency over security. Implementing broad, permissive firewall rules without a clear understanding of the traffic or the security implications is another failure. This approach increases the attack surface and can lead to security breaches, violating the principle of least privilege and potentially contravening compliance requirements for network segmentation and access control. It shows a lack of due diligence and a failure to properly assess risk, escalating the issue to management without conducting any initial investigation is professionally deficient. While escalation is sometimes necessary, doing so without attempting to diagnose the problem demonstrates a lack of initiative and problem-solving skills. It can lead to uninformed decisions by management and delays in resolving the actual issue, potentially impacting business operations, and failing to meet professional obligations to resolve technical challenges effectively. Professional reasoning. Professionals should employ a structured decision-making framework that begins with problem identification and data gathering. This involves understanding the business impact, the technical environment, and any relevant compliance obligations. The next step is to formulate hypotheses about the root cause and design experiments or investigations to test these hypotheses. Solutions should be developed based on evidence, with a strong emphasis on testing and validation in a non-production environment before deployment. Change management procedures must be followed rigorously. Throughout this process, professionals must maintain a commitment to security best practices, ethical conduct, and regulatory compliance, ensuring that all actions are justifiable and documented. Question 8. The review process indicates that users are reporting intermittent connectivity issues to a critical internal application hosted behind an NSX Edge Services gateway. Initial investigation suggests a potential misconfiguration in the Edge Services firewall rules. Which of the following actions represents the most professional and effective approach to resolving this issue? Option A. Initiate a full rollback of the NSX Edge Services gateway configuration to the last known good state without further investigation. Option B. Temporarily disable the most recently added firewall rule on the Edge Services gateway to see if connectivity is restored, with a plan to re-enable it if no change occurs. Option C. Utilize NSX diagnostic tools to analyze firewall rule hit counts and traffic logs for the affected application's traffic, and then make a targeted, documented modification or temporary bypass of the identified problematic rule with a clear rollback strategy. Option D. Immediately disable all firewall rules on the Edge Services gateway to ensure full network access, and then investigate the specific rule later. The correct answer is B. Temporarily disable the most recently added firewall rule on the Edge Services gateway to see if connectivity is restored, with a plan to re-enable it if no change occurs. Explanation. The review process indicates a potential misconfiguration in the NSX Edge Services firewall rules, specifically impacting traffic flow for a critical application. This scenario is professionally challenging because it requires a rapid and accurate assessment of the impact on business operations, while adhering to strict security policies and potentially compliance requirements. The urgency of restoring service must be balanced against the risk of introducing further security vulnerabilities or violating established change management procedures. The correct approach involves a systematic, evidence-based investigation. This means leveraging NSX's built-in diagnostic tools, such as firewall rule hit counts, traffic logs, and packet captures, to pinpoint the exact rule causing the issue. The decision to temporarily disable or modify the rule should be made only after a thorough risk assessment, with immediate rollback plans in place. This aligns with best professional practices by prioritizing operational continuity while maintaining security posture through controlled and documented changes. It also implicitly adheres to principles of least privilege and defense in depth, ensuring that any temporary bypass is minimal and time-bound. An incorrect approach would be to indiscriminately disable all firewall rules on the Edge Services gateway. This is a significant regulatory and ethical failure because it completely negates the security controls designed to protect the network, exposing the environment to a wide range of threats, violates the principle of least privilege, and demonstrates a lack of due diligence in troubleshooting. Another incorrect approach is to immediately escalate to a full system rollback without attempting to isolate the specific misconfiguration. This can be disruptive, time-consuming, and may not address the root cause if the issue is localized. It also bypasses the opportunity to learn from the incident and improve future configurations. Finally, making undocumented changes to firewall rules, even if seemingly minor, is a critical failure. It undermines auditability, makes troubleshooting future issues more difficult, and can lead to compliance violations if change control processes are not followed. Professionals should employ a structured decision-making framework for such situations. This framework typically involves 1. Incident identification and scoping, clearly define the problem and its impact. 2. Information gathering. Collect all relevant data using available tools. 3. Hypothesis generation. Formulate potential causes for the issue. 4. Testing and validation. Systematically test hypotheses, prioritizing least disruptive methods. 5. Solution implementation. Apply the most effective and least risky solution with rollback plans. 6. Documentation and review. Record all actions taken and conduct a post-incident review to prevent recurrence. Question 9. The analysis reveals that a financial services organization is migrating its critical applications to a private cloud environment utilizing VMware NSX 4X. The primary security objective is to implement robust microsegmentation to protect sensitive customer data and comply with stringent financial regulations. The organization has a mature IT operations team, but is concerned about introducing excessive management complexity. Given these considerations, which NSXT deployment strategy for the distributed firewall would best achieve the security objectives while managing operational overhead? Option A. Leveraging a distributed firewall deployment model that focuses on segmenting at the logical switch level, creating broad security zones for application categories rather than individual workloads. Option B. Utilizing a distributed firewall deployment model that prioritizes workload-centric segmentation for critical applications and data tiers, while employing logical switch-level segmentation for less sensitive environments, with a clear strategy for policy automation and lifecycle management. Option C. Implementing a highly granular, workload-centric distributed firewall deployment, creating distinct security groups and policies for each individual virtual machine or application tier. Option D. Deploying the distributed firewall in a gateway-centric model, relying on NSX edge nodes for all internal segmentation and policy enforcement. The correct answer is D. Deploying the distributed firewall in a gateway-centric model, relying on NSX edge nodes for all internal segmentation and policy enforcement. Explanation. The scenario presents a common challenge in network security architecture, balancing the need for granular control and segmentation with operational complexity and potential performance impacts. The professional must evaluate different NSXT deployment models, considering their implications for security policy enforcement, management overhead, and adherence to best practices for microsegmentation. The core of the professional challenge lies in selecting a deployment strategy that maximizes security benefits while remaining manageable and efficient within the given constraints. The correct approach prioritizes a distributed firewall deployment model that leverages NSXT's capabilities for microsegmentation at the virtual machine, VM, or workload level. This aligns with the principle of least privilege and defense in depth, allowing for highly granular security policies to be applied directly to individual workloads. This distributed model is generally considered best practice for modern network security architectures, as it moves security enforcement closer to the assets being protected, reducing the attack surface and improving the effectiveness of security controls. It also facilitates dynamic policy management, which is crucial in agile cloud-native environments. From a regulatory perspective, this approach supports compliance with frameworks that mandate strict access controls and data segmentation, such as those requiring separation of sensitive data or adherence to specific security zones. An incorrect approach would be to rely solely on a gateway firewall for segmentation. While gateway firewalls are essential for perimeter security and intersegment traffic inspection, they are not designed for the granular, workload-centric security required for effective microsegmentation. This approach would lead to broader, less precise security policies, increasing the risk of lateral movement by attackers and making it difficult to enforce specific security requirements for individual applications or data sets. This failure to implement granular controls could lead to non-compliance with regulations requiring fine-grained access management. Another incorrect approach would be to over-segment the network to an impractical degree, creating an unmanageable number of security groups and policies. While the goal is granular control, excessive segmentation can lead to significant operational overhead, increased complexity in troubleshooting, and potential performance degradation due to the sheer volume of policy enforcement points. This can indirectly lead to security gaps if policies become too difficult to maintain or if legitimate traffic is inadvertently blocked. This approach might also be seen as failing to implement security in a proportionate manner, a common consideration in many regulatory frameworks. Finally, an approach that neglects to leverage NSX's distributed firewall capabilities in favor of traditional physical firewalling for internal segmentation would be incorrect. This would fail to take advantage of the inherent benefits of a software-defined networking approach for security, such as automation, dynamic policy updates, and integration with cloud orchestration platforms. It would also likely result in a less agile and more costly security infrastructure, potentially hindering the organization's ability to adapt to evolving threats and compliance requirements. Professionals should employ a decision-making framework that begins with understanding the organization's security objectives, compliance mandates, and operational capabilities. This involves assessing the threat landscape, identifying critical assets, and defining the desired level of segmentation. The next step is to evaluate different NSXT deployment models against these requirements, considering factors like ease of management, scalability, performance impact, and integration with existing security tools. A phased implementation approach, starting with critical applications and gradually expanding, is often advisable to mitigate risks and ensure successful adoption. Continuous monitoring and auditing of security policies are essential to maintain effectiveness and compliance. Question 10. Quality control measures reveal that a proposed VMware NSX security policy designed to enhance network segmentation for a critical financial services application has not undergone a comprehensive impact assessment beyond initial functional testing. The policy is scheduled for immediate production deployment. What is the most professional and risk-averse approach to proceed? Option A. Halt the production deployment and initiate a phased rollout strategy, beginning with a pilot deployment to a subset of non-critical systems, followed by a controlled expansion to production environments with continuous performance and availability monitoring. Option B. Proceed with the immediate production deployment of the NSX security policy as scheduled, relying on post-deployment monitoring to address any unforeseen issues. Option C. Implement the NSX security policy in production, but disable certain security features temporarily to minimize potential impact, planning to re-enable them once stability is confirmed. Option D. Deploy the NSX security policy to a staging environment that mirrors production and conduct extensive performance and load testing before considering any production deployment. Correct answer is B. Proceed with the immediate production deployment of the NSX security policy as scheduled, relying on post-deployment monitoring to address any unforeseen issues. Explanation. Scenario analysis. This scenario presents a common challenge in network security deployments, balancing the need for robust security controls with the operational requirements of business-critical applications. Challenge lies in accurately assessing the potential impact of a new NSX security policy on existing application performance and availability. A misjudgment can lead to significant service disruptions, financial losses, and reputational damage. The professional must navigate technical complexities, understand application dependencies, and communicate effectively with stakeholders to mitigate risks. Correct approach analysis. The correct approach involves a phased, controlled rollout of the NSX security policy, coupled with comprehensive monitoring and validation. This aligns with best practices for change management and risk mitigation in IT infrastructure. Specifically, it emphasizes 1. Pre-deployment testing in a non-production environment to identify potential conflicts or performance degradation. 2. A pilot deployment to a limited set of production systems or applications to observe real-world impact. 3. Continuous monitoring of key performance indicators, KPI, and security logs during and after deployment. 4. A well-defined rollback plan in case of unforeseen issues. This methodical approach minimizes the risk of widespread disruption, allows for timely identification and remediation of problems, and ensures that the security policy meets its objectives without compromising business operations. This is crucial for maintaining service availability and compliance with operational standards. Correct approaches analysis. Implementing the NSX security policy directly into the production environment without prior testing or a phased rollout is a significant regulatory and ethical failure. It demonstrates a disregard for risk management principles and could lead to a breach of service level agreements, SLAs, with internal or external customers, potentially violating contractual obligations and industry standards for operational resilience. Deploying the policy and then waiting for user complaints or system alerts before taking action is reactive and unprofessional. This approach fails to proactively identify and address potential issues, leading to prolonged outages and impacting business continuity. It also suggests a lack of due diligence in assessing the impact of changes, which can be seen as a failure to uphold professional responsibility and potentially violate internal IT governance policies. Focusing solely on the security benefits of the NSX policy without considering its operational impact is an incomplete assessment. While security is paramount, it must be balanced with the need for system availability and performance. Neglecting the operational aspect can lead to unintended consequences that undermine the overall value of the security enhancement and can result in non-compliance with operational uptime requirements. Professional reasoning. Professionals should adopt a risk-based approach to network security changes. This involves a thorough impact assessment that considers technical, operational, and business implications. The process should include 1. Understanding the existing environment and application dependencies. 2. Defining clear objectives for the NSX policy. 3. Developing a comprehensive testing and validation strategy. 4. Planning for a phased deployment with robust monitoring. 5. Establishing a clear rollback procedure. 6. Communicating effectively with all relevant stakeholders throughout the process. This structured decision-making process ensures that changes are implemented safely, effectively, and with minimal disruption to business operations, upholding professional standards and regulatory compliance. Question 11. The efficiency study reveals a significant increase in network latency and packet loss following the implementation of a new NSXT microsegmentation policy. Which of the following actions best represents a professional and compliant approach to addressing this issue? Option A. Make arbitrary adjustments to various NSXT configuration parameters, including security groups and logical switches, until network performance improves. Option B. Assume the performance degradation is due to external network congestion and focus on optimizing upstream network devices without examining the NSXT configuration. Option C. Immediately revert the NSXT microsegmentation policy to its previous state to restore network performance and address the security implications later. Option D. Conduct a detailed analysis of NSXT flow logs, distributed firewall rules, and network performance metrics to identify specific policy elements contributing to the latency and packet loss, and then iteratively adjust the policy based on findings. Correct answer is D. Conduct a detailed analysis of NSXT flow logs, distributed firewall rules, and network performance metrics to identify specific policy elements contributing to the latency and packet loss, and then iteratively adjust the policy based on findings. Explanation. The efficiency study reveals a significant increase in network latency and packet loss following the implementation of a new NSXT microsegmentation policy. This scenario is professionally challenging because it directly impacts application performance and user experience, potentially leading to business disruptions and financial losses. The core challenge lies in balancing security posture with operational efficiency, requiring a nuanced understanding of NSXT capabilities and their real-world impact. The correct approach involves a systematic and data-driven impact assessment. This means meticulously analyzing the NSXT configuration, correlating the observed performance degradation with specific policy rules, and identifying any misconfigurations or unintended consequences. It requires leveraging NSXT's built-in monitoring and troubleshooting tools, such as flow monitoring, packet capture, and distributed firewall logs, to pinpoint the root cause. This approach represents best professional practice because it adheres to the principle of due diligence and responsible system management. By thoroughly investigating the issue, the professional demonstrates a commitment to understanding and mitigating the impact of security controls, ensuring that security measures do not unduly hinder business operations. This aligns with the ethical obligation to provide secure and reliable network services. An incorrect approach would be to immediately roll back the microsegmentation policy without a thorough investigation. This fails to address the underlying issue and leaves the network vulnerable to potential threats that the policy was designed to mitigate. It also represents a failure in the impact assessment process, as it bypasses the critical step of understanding asterisk, why the performance degradation occurred. Ethically, this could be seen as neglecting the security responsibilities. Another incorrect approach is to attribute the performance issues solely to external factors without examining the NSX configuration. This demonstrates a lack of accountability and a failure to perform a comprehensive impact assessment. It ignores the possibility that the implemented NSX policy itself is the direct cause of the problem, leading to a missed opportunity for optimization and potentially leaving security gaps unaddressed. This approach violates the professional standard of thorough investigation and problem solving. A third incorrect approach is to make broad, unsubstantiated changes to the NSX configuration in an attempt to resolve the latency. This shotgun approach is not only inefficient but also highly risky, as it could introduce new problems or further degrade performance. It lacks the systematic analysis required for a proper impact assessment and demonstrates a disregard for the potential consequences of poorly planned changes. This is professionally unsound and ethically questionable due to the potential for causing further harm. The professional decision-making process in such situation should involve a structured approach. First, clearly define the observed problem and its impact. Second, gather all relevant data from NSX and other monitoring tools. Third, hypothesize potential causes, prioritizing those directly related to the recent NSX changes. Fourth, test these hypotheses systematically, making controlled changes and observing their effects. Fifth, document all findings and actions. And finally, implement a permanent solution that balances security and performance. Question 12. During the evaluation of a planned VMware NSX X deployment, which approach best ensures that the organization maintains its regulatory compliance posture and avoids introducing new risks? Option A. Focus the impact assessment solely on the technical aspects of NSX X deployment, such as IP addressing and routing, assuming that compliance is a separate, independent concern. Option B. Conduct a comprehensive impact assessment that maps the new NSX X functionalities and network flows against all relevant regulatory requirements and existing compliance controls, identifying any gaps or necessary adjustments. Option C. Rely on the assumption that existing security and compliance controls will automatically adapt to the new virtualized network environment without explicit revalidation. Option D. Prioritize the technical performance and feature set of NSX X, addressing compliance concerns only if specific regulatory issues are flagged by external auditors post-implementation. Correct answer is B. Conduct a comprehensive impact assessment that maps the new NSX X functionalities and network flows against all relevant regulatory requirements and existing compliance controls, identifying any gaps or necessary adjustments. Explanation. This scenario presents a professional challenge due to the inherent complexity of assessing the impact of a significant network infrastructure change on an organization's compliance posture. The introduction of VMware NSX X, with its advanced microsegmentation and network virtualization capabilities, can fundamentally alter data flow, access controls, and security policies. A thorough impact assessment is critical to ensure that the new environment continues to meet all applicable regulatory requirements without introducing new vulnerabilities or compliance gaps. The challenge lies in identifying all potential areas of impact across various compliance domains, from data privacy to operational resilience, and ensuring that the assessment is comprehensive and accurate. The correct approach represents best professional practice because it systematically identifies and evaluates the potential effects of the NSX X deployment on existing compliance controls and regulatory obligations. This proactive and structured methodology ensures that any deviations or new requirements are identified early, allowing for remediation before deployment or during the implementation phase. This aligns with the principles of risk management and due diligence mandated by regulatory frameworks that require organizations to maintain a secure and compliant environment. By focusing on specific compliance controls and their interaction with the new technology, this approach minimizes the risk of non-compliance and associated penalties. An incorrect approach that focuses solely on the technical implementation of NSX X without considering its broader compliance implications represents a significant regulatory and ethical failure. It demonstrates a lack of understanding of the organization's legal and regulatory obligations, potentially leading to the deployment of a system that inadvertently violates data protection laws, security standards, or industry-specific regulations. This failure to integrate compliance considerations into the technology deployment process can result in data breaches, unauthorized access, or operational disruptions, all of which carry severe legal and financial consequences. Furthermore, it breaches the ethical responsibility of IT professionals to ensure that technology solutions support, rather than undermine, the organization's compliance objectives. Another incorrect approach that relies on assumptions about existing controls continuing to function effectively without explicit validation is also professionally unacceptable. This approach ignores the fundamental principle that changes in infrastructure can render previously effective controls obsolete or insufficient. It is a failure of due diligence to assume that the new network architecture will automatically maintain the same level of security and compliance as the old one. This oversight can lead to undetected compliance gaps, leaving the organization exposed to regulatory scrutiny and potential enforcement actions. The professional decision-making process for such situations should involve a multidisciplinary team including network engineers, security architects, compliance officers, and legal counsel. The process should begin with a clear understanding of all relevant regulatory frameworks, a detailed inventory of existing compliance controls, and their mapping to current infrastructure should be established. The impact assessment should then systematically analyze how the proposed NSX 4X deployment will affect each of these controls, identifying any necessary modifications, new controls, or potential conflicts. This should be followed by a risk assessment to prioritize identified issues and develop a remediation plan. Continuous monitoring and validation post-deployment are also crucial to ensure ongoing compliance. Question 13. Which approach would be most effective in ensuring that a VMware NSX 4X deployment meets the stringent data protection and privacy regulations of the financial services industry, specifically concerning the logging and auditing of network traffic flows and security policy changes? Option A. Configuring NSX 4X to log only critical security events, assuming that less critical traffic data is not relevant for regulatory compliance in the financial sector. Option B. Focusing primarily on the performance and scalability benefits of NSX 4X, with a secondary, ad hoc effort to address regulatory logging and auditing requirements only if specific audit findings are reported. Option C. Deploying NSX 4X with default logging settings and relying on periodic manual reviews of network activity to identify potential compliance issues as they arise. Option D. Implementing comprehensive logging for all NSX 4X network traffic and security policy modifications, ensuring logs are retained in a secure, immutable storage, and establishing automated alerts for any policy deviations or suspicious activity, all validated against specific financial regulatory audit requirements. The correct answer is D. Implementing comprehensive logging for all NSX 4X network traffic and security policy modifications, ensuring logs are retained in a secure, immutable storage, and establishing automated alerts for any policy deviations or suspicious activity, all validated against specific financial regulatory audit requirements. Explanation. This scenario presents a professional challenge due to the inherent tension between implementing advanced network security features in VMware NSX 4X and adhering to strict regulatory compliance requirements. Organizations operating in regulated industries, such as finance or healthcare, must demonstrate that their network security controls meet specific standards, often involving detailed logging, auditing, and access control mechanisms. The complexity of NSX 4X, with its distributed architecture and software-defined networking capabilities, can make it difficult to ensure that all security configurations are both effective and compliant without careful planning and validation. The need to balance innovation and agility with robust security and compliance mandates requires a methodical and informed approach. The correct approach represents best professional practice because it prioritizes a proactive and integrated strategy for regulatory compliance. By embedding compliance considerations into the design and implementation phases of NSX 4X deployments, organizations can avoid costly remediation efforts later. This involves understanding the specific regulatory frameworks applicable to the organization's industry and geographic location, and then mapping these requirements to NSX 4X features and functionalities. For example, If a regulation mandates detailed audit trails for network access changes, the chosen approach would ensure that NSX 4X logging is configured to capture this information, and that these logs are securely stored and accessible for audit purposes. This aligns with principles of security by design and privacy by design, which are increasingly becoming regulatory expectations. An incorrect approach that focuses solely on deploying NSX 4X features without explicit consideration for regulatory requirements would be professionally unacceptable. This could lead to significant compliance gaps, potentially resulting in regulatory fines, reputational damage, and loss of customer trust. For instance, if a regulation requires granular access control to network security policies, and the implementation defaults to broader administrative roles without proper justification or documentation, it would violate the principle of least privilege and fail to meet compliance mandates. Another incorrect approach, which involves retrofitting compliance controls after deployment, is inefficient and prone to errors. It often leads to a fragmented security posture and may not fully address the underlying compliance obligations, creating a false sense of security and a high risk of non-compliance. The professional decision-making process for similar situations should involve a structured risk assessment and compliance mapping exercise. This begins with identifying all relevant regulatory obligations. Next, a thorough understanding of the NSX 4X capabilities and how they can be configured to meet these obligations is crucial. This should be followed by a design phase where compliance requirements are integrated into the network architecture and security policies. Finally, ongoing monitoring, auditing, and regular reviews are essential to ensure continuous compliance and adapt to evolving regulatory landscapes. Question 14. Compliance review shows that a critical financial services application hosted on VMware NSX is experiencing intermittent connectivity issues, leading to user complaints and potential business impact. The network operations team is proposing to relax the existing distributed firewall rules for the application's subnet to a broader IP range to alleviate these issues, citing the need for immediate resolution. What is the most appropriate course of action to address the connectivity issues while maintaining regulatory compliance and security best practices? Option A. Disable the NSX distributed firewall rules for the application subnet temporarily until the connectivity issues are fully resolved and a root cause analysis can be performed. Option B. Implement network address translation, NAT, for the application subnet to mask internal IP addresses, assuming this will resolve the connectivity issues and provide an adequate security layer. Option C. Immediately broaden the NSX distributed firewall rules for the application subnet to encompass a wider IP address range, effectively reducing the granularity of the security policy to improve connectivity. Option D. Conduct a detailed analysis of the NSX distributed firewall rules applied to the application's workload, identifying specific denied traffic flows that are legitimate for the application's operation. Refine these rules to permit only the necessary communication paths, leveraging NSX's capabilities for dynamic grouping and context-aware policies, and implement a formal change management process for any modifications. Correct answer is D. Conduct a detailed analysis of the NSX distributed firewall rules applied to the application's workload, identifying specific denied traffic flows that are legitimate for the application's operation. Refine these rules to permit only the necessary communication paths, leveraging NSX's capabilities for dynamic grouping and context-aware policies, and implement a formal change management process for any modifications. Explanation. Scenario analysis. This scenario presents a common challenge in network security and compliance, balancing the need for granular network segmentation and access control with the operational demands of a dynamic cloud environment. The professional must navigate the complexities of NSX's distributed firewall capabilities, microsegmentation policies, and the potential for misconfigurations that could lead to security vulnerabilities or compliance violations. The challenge lies in ensuring that the implemented security policies are not only technically sound, but also align with the organization's risk appetite and regulatory obligations, particularly concerning data protection and access control for sensitive workloads. The rapid pace of cloud deployments and the ephemeral nature of some cloud resources add further complexity, requiring a proactive and adaptable security posture. Correct approach analysis. The correct approach involves a systematic review and refinement of existing NSX distributed firewall rules. This process should prioritize the principle of least privilege, ensuring that only necessary communication paths are permitted between workloads. Leveraging NSXD's capabilities for dynamic grouping and context-aware policies, based on attributes like VM tags or security groups, allows for more agile and accurate policy enforcement as workloads change. This aligns with best practices for zero-trust security architectures and regulatory requirements that mandate strict access controls and data segregation. The focus on auditing existing rules and implementing a robust change management process for any modifications directly addresses the need for accountability and prevents unintended security gaps. This approach ensures that security policies are continuously validated against operational needs and compliance mandates, fostering a secure and compliant network environment. Incorrect approaches analysis. Implementing broad, overly permissive firewall rules based on IP address ranges without further segmentation or context is a significant regulatory and ethical failure. This approach violates the principle of least privilege, increasing the attack surface and the risk of unauthorized access to sensitive data, which is a direct contravention of data protection regulations. It also fails to provide the necessary granularity for auditing and incident response, making it difficult to pinpoint the source of a breach. Disabling distributed firewall rules for specific segments to improve application performance without a thorough risk assessment and compensating controls represents a critical security and compliance lapse. This action bypasses fundamental security mechanisms designed to protect workloads and data, potentially exposing them to threats. It demonstrates a disregard for established security policies and regulatory mandates that require robust protection of network resources. Relying solely on network address translation, NAT, to obscure internal IP addresses as a primary security control without implementing proper firewall rules is an inadequate and misleading security practice. NAT is a network function, not a security control, that enforces access policies. It does not prevent unauthorized access to services or data within the network, leaving workloads vulnerable and failing to meet compliance requirements for access control and segmentation. Professional reasoning. Professionals facing this situation should adopt a structured, risk-based approach. First, understand the specific regulatory requirements applicable to the organization's data and workloads. Second, conduct a comprehensive audit of the current NSX security posture, identifying any deviations from policy or potential vulnerabilities. Third, prioritize the application of the principle of least privilege, meticulously defining necessary communication flows. Fourth, leverage NSX's advanced features, such as microsegmentation and dynamic grouping, to create context-aware and adaptable security policies. Finally, establish a rigorous change management process for all security policy modifications, ensuring proper review, testing, and documentation to maintain compliance and security integrity. Question 15. Regulatory review indicates that a critical business application is undergoing a significant update, requiring changes to its network connectivity and access patterns. The network security team is responsible for ensuring that these changes do not compromise the organization's security posture or violate any implicit compliance requirements for data protection within the NSX environment. The team needs to determine the most effective strategy for updating the microsegmentation policies associated with this application. Option A. Conduct a detailed analysis of the application's communication flows and dependencies. Define granular security policies based on the principle of least privilege using NSX security groups and tags, and integrate these policy updates into the existing change management process for review and approval before deployment. Option B. Implement the new connectivity requirements by creating a new, broader security group that encompasses all servers involved in the updated application, and then apply a single, less restrictive firewall rule to this group. Option C. Immediately update the existing firewall rules to allow all necessary traffic for the application update, with the intention of refining the policies after the application is confirmed to be stable. Option D. Rely on the existing perimeter firewall rules to protect the application, assuming that internal traffic is inherently secure within the virtualized environment, and no specific microsegmentation policy updates are required for this application change. The correct answer is B. Implement the new connectivity requirements by creating a new, broader security group that encompasses all servers involved in the updated application, and then apply a single, less restrictive firewall rule to this group. Explanation: the scenario presents a common challenge in network security, balancing the need for robust security controls with the operational requirements of a dynamic environment. The specific challenge lies in ensuring that security policies, particularly those related to microsegmentation and network access control, remain effective and compliant with evolving business needs without introducing vulnerabilities or operational disruptions. The regulatory framework for this exam, VMware NSX 4 X Professional V2, implies adherence to best practices and potentially specific industry standards for network security and data protection, though no explicit external jurisdiction is provided. Thus, we rely on the implicit framework of professional NSX deployment and management. The correct approach emphasizes a proactive and integrated strategy for managing security policies. This involves understanding the business context of network changes, utilizing NSX's capabilities for granular policy definition and enforcement, and implementing a robust change management process. This aligns with best professional practice by ensuring that security is not an afterthought but a fundamental component of network operations. It promotes a least privilege model, reduces the attack surface, and facilitates compliance by maintaining a clear audit trail of policy configurations and their justification. The professional justification stems from the principle of defense in depth and the need for continuous security posture management in a virtualized environment. An incorrect approach might involve implementing security policies in isolation from operational workflows, leading to conflicts and potential security gaps. For instance, applying overly restrictive policies without considering application dependencies could disrupt critical business functions, forcing a hasty rollback that might bypass proper security review. Another incorrect approach could be relying solely on perimeter security without leveraging microsegmentation, leaving internal east-west traffic vulnerable. This fails to meet the advanced security posture expected in a modern virtualized network. A third incorrect approach might be to delay policy updates, creating a drift between the intended security state and the actual deployed configuration, which is a direct contravention of maintaining an effective security posture and could lead to compliance issues. The professional decision-making process should involve a thorough understanding of the business requirements driving network changes, a comprehensive assessment of the security implications of those changes, and the strategic application of NSX features to achieve both security and operational objectives. This includes leveraging NSX's distributed firewall, security groups, and application profiles to create dynamic and context-aware security policies. A key element is fostering collaboration between security and operations teams to ensure that security policies are understood, implemented, and maintained effectively throughout the network lifecycle. Question 16. Risk assessment procedures indicate that a critical vulnerability has been identified in the VMware NSX 4 X environment, posing a significant threat to sensitive customer data. The vendor has released a patch, but its deployment across all production segments is projected to cause a minimum of 12 hours of network downtime, impacting critical business operations. Alternative temporary mitigation strategies, such as implementing specific firewall rules and disabling certain non-essential services, have been proposed to reduce the immediate risk while a full patch deployment is scheduled. Which of the following approaches best balances the immediate need for security remediation with the imperative to maintain business continuity and comply with regulatory mandates? Option A. Delay all remediation efforts until a comprehensive network redesign can be completed to address the underlying architectural issues. Option B. Implement the proposed temporary mitigation strategies to reduce the immediate risk and schedule the full patch deployment during the next planned maintenance window. Option C. Immediately deploy the patch to all production segments, accepting the 12-hour downtime to eliminate the critical vulnerability. Option D. Bypass the standard change management and risk assessment procedures to deploy the patch as quickly as possible, prioritizing immediate vulnerability closure. The correct answer is C. Immediately deploy the patch to all production segments, accepting the 12-hour downtime to eliminate the critical vulnerability. Explanation: scenario analysis. This scenario presents a professional challenge in managing network security posture within a regulated environment. The core difficulty lies in balancing the immediate need for operational continuity with the imperative to adhere to stringent security compliance mandates. The organization is facing a critical vulnerability that could lead to a significant breach, but the proposed remediation steps carry a high risk of disrupting essential business functions. This requires a nuanced approach that prioritizes both security and business continuity, demanding careful consideration of potential impacts and the justification for any deviations from standard operating procedures. The pressure to act quickly against a known threat, while simultaneously mitigating the risk of causing further operational harm, necessitates a robust decision-making framework grounded in risk management principles and regulatory adherence. Correct approach analysis. The correct approach involves a phased remediation strategy that prioritizes the most critical vulnerabilities while implementing temporary mitigation measures for others. This aligns with best practices in cybersecurity risk management and regulatory compliance. By first addressing the highest risk vulnerabilities with minimal disruption, the organization can reduce its immediate attack surface. Concurrently, implementing temporary workarounds or compensating controls for less critical but still significant vulnerabilities allows for continued operations. This approach demonstrates due diligence in protecting sensitive data and systems, as required by regulatory frameworks that mandate proactive security measures and risk mitigation. It also reflects a responsible approach to business continuity, ensuring that essential services are maintained during the remediation process. This strategy is often supported by regulatory guidance that encourages risk-based prioritization and the use of compensating controls when immediate full remediation is not feasible. Incorrect approaches analysis. One incorrect approach is to immediately deploy the patch for all identified vulnerabilities without assessing the potential operational impact. This fails to acknowledge the regulatory requirement for business continuity and could lead to significant service disruptions, potentially violating service-level agreements or other operational compliance obligations. It also demonstrates a lack of risk-based decision-making, as not all vulnerabilities carry the same level of immediate threat or impact. Another incorrect approach is to delay all remediation efforts until a maintenance window can be scheduled, which may be weeks or months away. This is a direct violation of the principle of timely vulnerability management and proactive security. Regulatory bodies expect organizations to address known security risks promptly, especially those that could lead to a data breach. Such a delay would expose the organization to unacceptable levels of risk and likely constitute a compliance failure. A third incorrect approach is to bypass the security review process and implement the patch directly to expedite the remediation. This undermines the established security governance and change management processes, which are often mandated by regulations to ensure that security changes are properly vetted and do not introduce new risks. It also bypasses the critical step of assessing operational impact, which is essential for maintaining business continuity. Professional reasoning. Professionals facing such a dilemma should employ a structured risk assessment and management process. This involves 1. Thoroughly understanding the nature and severity of each identified vulnerability. 2. Assessing the potential business impact of each vulnerability being exploited. 3. Evaluating the risks associated with each proposed remediation step, including operational disruption. 4. Prioritizing remediation efforts based on a combination of vulnerability severity and business impact. 5. Developing a phased remediation plan that includes temporary mitigation strategies where full remediation is not immediately feasible. 6. Documenting all decisions, justifications, and risk acceptance rationale. 7. Communicating the plan and its implications to relevant stakeholders, including management and compliance officers. This systematic approach ensures that decisions are informed, defensible, and aligned with both security best practices and regulatory requirements. Question 17. The risk matrix shows a moderate likelihood of a security breach due to misconfigured NSX firewall rules, with a high potential impact on critical business operations. Which of the following remediation strategies best addresses this risk while adhering to professional security best practices? Option A. Schedule a comprehensive manual audit of all NSX firewall rules by the security team to be completed within the next quarter. Option B. Increase the logging verbosity of all existing NSX firewall rules to capture more detailed information for post-incident forensic analysis. Option C. Implement microsegmentation using NSX distributed firewall policies based on workload identity and context, coupled with integration into a SIEM for continuous monitoring and automated response to policy violations. Option D. Temporarily disable the NSX firewall rules identified as causing alerts to minimize operational disruption, with a plan for future review. The correct answer is C. Implement microsegmentation using NSX distributed firewall policies based on workload identity and context, coupled with integration into a SIEM for continuous monitoring and automated response to policy violations. Explanation: the risk matrix shows a moderate likelihood of a security breach due to misconfigured NSX firewall rules, with a high potential impact on critical business operations. This scenario is professionally challenging because it requires balancing security posture with operational agility and cost-effectiveness. Network engineers must interpret the risk assessment accurately, understand the implications of potential breaches, and propose solutions that are both technically sound and compliant with organizational policies and industry best practices, without introducing new vulnerabilities. The challenge lies in selecting the most appropriate remediation strategy from several technically feasible options, each with its own trade-offs. The correct approach represents best professional practice because it directly addresses the identified risk by implementing a layered security strategy that includes proactive monitoring and automated remediation. This aligns with the principle of defense in depth, a fundamental security concept. Specifically, leveraging NSX's distributed firewall capabilities to enforce microsegmentation and applying security policies based on identity and context, rather than just IP addresses, significantly reduces the attack surface. Furthermore, integrating with security information and event management, SIEM, systems for continuous monitoring, and establishing automated response mechanisms for detected policy violations ensures timely mitigation, minimizing potential impact. This proactive and automated approach is favored by modern security frameworks and is often a requirement for compliance with data protection regulations that mandate timely breach detection and response. An incorrect approach that involves simply increasing the logging verbosity of existing firewall rules fails to address the root cause of the risk, the misconfiguration itself. While enhanced logging might aid in post-incident analysis, it does not prevent the breach or limit its impact. This approach is professionally unacceptable as it represents a passive response to a known, active threat, potentially violating due diligence requirements to actively mitigate risks. Another incorrect approach, which suggests disabling the firewall rules that are causing the alerts to reduce operational disruption, is also professionally unacceptable. This directly contradicts the purpose of the firewall and introduces a severe security vulnerability. It prioritizes short-term operational convenience over long-term security, a decision that could lead to significant financial and reputational damage, and likely violate regulatory requirements for maintaining a secure network infrastructure. A third incorrect approach, which proposes a manual review of all firewall rules by the security team without any automation, is inefficient and prone to human error. A manual review can be thorough. In a large and dynamic environment, it is unlikely to keep pace with network changes, leading to a perpetual state of vulnerability. This approach fails to leverage the capabilities of NSX for efficient security management and could be considered negligent if it leads to a preventable breach. The professional reasoning process for this situation should involve 1. Thoroughly understanding the risk assessment and its implications. 2. Evaluating potential remediation strategies against established security principles and organizational policies. 3. Considering the technical feasibility, operational impact, and cost-effectiveness of each option. 4. Prioritizing solutions that offer proactive threat mitigation and automated response capabilities. 5. Documenting the chosen approach and its justification, including any residual risks. 6. Ensuring the chosen solution aligns with relevant regulatory compliance mandates. Question 18. Implementation of a distributed firewall strategy in a VMware NSX environment to achieve microsegmentation for a multi-tier application. Considering both security efficacy and operational manageability, what is the most effective approach? Option A. Utilize a distributed firewall, but implement overly permissive, allow all rules for all internal traffic within the application's tiers to simplify initial deployment. Option B. Configure a single, broad security policy at the network perimeter to control all inbound and outbound traffic for the application subnet. Option C. Apply security policies directly to the VNICs of virtual machines, leveraging NSX distributed firewall rules based on security tags and logical network segments. Option D. Deploy a dedicated hardware security appliance in front of the application's load balancer to inspect all traffic. While relying on default, allow rules within the NSX distributed firewall for internal traffic. The correct answer is C. Apply security policies directly to the VNICs of virtual machines, leveraging NSX distributed firewall rules based on security tags and logical network segments. Explanation. The scenario presents a common challenge in network security, balancing the need for granular traffic control with the operational overhead of managing complex security policies. Specifically, the implementation of distributed firewall rules in a large-scale NSX environment requires careful consideration of policy enforcement points, rule precedents, and potential performance impacts. The professional challenge lies in selecting an approach that is both effective in meeting security objectives and efficient from an operational and performance perspective, while adhering to best practices for network segmentation and compliance. The correct approach represents best professional practice because it leverages the inherent capabilities of NSX to enforce security policies at the virtual machine, VM Network Interface Card, VNIC level. This distributed enforcement model minimizes the need for centralized hardware appliances, reduces network latency by processing traffic closer to the source, and allows for dynamic policy updates that are automatically applied to workloads as they move or scale. This aligns with the principle of least privilege and microsegmentation, which are foundational to modern network security architectures and often mandated by compliance frameworks. By applying rules directly to the VNIC, administrators ensure that security policies are tightly coupled with the workloads they protect, regardless of their physical location or IP address. An incorrect approach that relies solely on perimeter firewalling fails to address the internal threat landscape and the risks associated with lateral movement of threats within the data center. This approach is ethically questionable, as it provides a false sense of security by neglecting internal segmentation, leaving critical assets vulnerable to compromised endpoints. From a regulatory perspective, it likely falls short of requirements for data protection and breach prevention that necessitate internal controls. Another incorrect approach that involves excessive use of broad, allow all rules within the distributed firewall, even if intended for initial deployment simplicity, represents a significant ethical and regulatory failure. This practice directly contradicts the principle of least privilege, creating a wide attack surface and increasing the risk of unauthorized access and data exfiltration. It is professionally unacceptable as it abdicates the responsibility of granular security control, making it difficult to audit, troubleshoot, and enforce compliance with security policies. The professional decision-making process for similar situations should involve a thorough assessment of security requirements, including compliance mandates and threat models. This should be followed by an evaluation of the available NSX features and their suitability for the specific environment. Professionals must prioritize a defense-in-depth strategy that incorporates microsegmentation and distributed enforcement. They should also consider the operational impact, including policy management complexity and performance implications, and choose solutions that offer a balance between security efficacy and manageability. Continuous monitoring and auditing of security policies are essential to ensure ongoing compliance and effectiveness. Question 19. Quality control measures reveal that a newly deployed VMware NSX environment is experiencing inconsistent security policy enforcement for virtual machines within the same logical segment. Some VMs are being subjected to granular access controls, while others appear to have broader network access than intended, despite being assigned to the same security group. This inconsistency is impacting the ability to maintain a zero-trust security posture. Which of the following approaches best addresses this issue by ensuring consistent and granular security policy application at the VM level? Option A. Create broad distributed firewall rules that permit all traffic by default, and then implement specific rules to block known malicious traffic patterns. Option B. Implement a centralized network firewall appliance to inspect all intersegment traffic, relying on IP-based access control lists, ACL, For traffic management within segments. Option C. Manually configure distributed firewall rules based on the current IP addresses of all VMs within each logical segment, updating the rules whenever a VM's IP address changes. Option D. Configure distributed firewall rules to leverage security groups and VM attributes, ensuring policies are dynamically applied based on VM identity and context, and establish a default deny policy for all traffic, explicitly permitting only necessary communication. The correct answer is D. Configure distributed firewall rules to leverage security groups and VM attributes, ensuring policies are dynamically applied based on VM identity and context, and establish a default deny policy for all traffic, explicitly permitting only necessary communication. Explanation. Scenario analysis. This scenario presents a professional challenge in network security architecture design, specifically concerning the implementation of distributed firewall rules within a VMware NSX 4X environment. The challenge lies in balancing granular security policy enforcement with operational efficiency and compliance requirements. Misinterpreting or incorrectly applying NSX distributed firewall (DFW) capabilities can lead to security gaps, performance degradation, or non-compliance with internal security standards and potentially external regulatory mandates. Though this question focuses on internal best practices and NSX functionality, not specific external regulations, the need for a deep understanding of NSX DFW context and rule application order is paramount. Correct approach analysis. The correct approach leverages the inherent capabilities of NSX DFW to enforce security policies at the virtual machine, VM, network interface card, VNIC level. By applying security groups and rules based on VM attributes and network context, the DFW ensures that traffic is inspected and controlled as close to the source as possible, regardless of VM mobility or IP address changes. This aligns with the principle of least privilege and microsegmentation, which are foundational to modern network security architectures. The DFW's ability to dynamically apply policies based on VM identity and context is a key differentiator and represents best professional practice for achieving granular, efficient, and scalable security. Incorrect approaches analysis. An approach that relies solely on traditional network firewall appliances for intersegment traffic inspection, while ignoring the DFW's capabilities for intrasegment and VM-to-VM traffic, fails to fully utilize the NSX platform's security benefits. This creates a security gap for traffic that never traverses a physical network boundary, leaving VMs vulnerable to lateral movement by threats. It also introduces unnecessary latency and complexity by forcing traffic through a centralized inspection point, when distributed inspection would be more efficient. Another incorrect approach would be to implement overly broad DFW rules that permit all traffic by default, and then attempt to block specific malicious traffic. This violates the principle of least privilege and significantly increases the attack surface. It is far more secure and professionally sound to deny all traffic by default and explicitly permit only necessary communication. Finally, an approach that attempts to manage DFW rules solely based on IP addresses without utilizing security groups or VM attributes is brittle and difficult to maintain. IP addresses can change due to DHCP, VM reboots, or migration, rendering static rules ineffective and requiring constant manual updates. This leads to operational overhead and increases the risk of misconfiguration and security policy drift. Professional reasoning. Professionals should approach NSX DFW design by first understanding the desired security posture and the specific traffic flows that need to be controlled. This involves identifying critical assets, defining communication requirements between them, and applying the principle of least privilege. The next step is to map these requirements to NSX DFW constructs, prioritizing the use of security groups, VM tags, and other dynamic attributes for rule creation. Understanding the DFW rule processing order and context is crucial for ensuring policies are applied as intended. Regular review and auditing of DFW rules are essential to maintain security effectiveness and compliance. Question 20. Strategic planning requires a comprehensive approach to implementing NSX microsegmentation to enhance security posture against evolving threats. Given the organization's critical applications and the need to minimize operational disruption, Which of the following strategies for creating and deploying NSX firewall policies represents the most effective and compliant path forward? Option A. Prioritize rapid deployment by configuring, allow all firewall rules for all new segments and applications, with a commitment to tightening these rules over an extended period. Option B. Begin by analyzing traffic flows for critical applications, defining granular firewall rules based on observed communication patterns, and then deploying these policies iteratively, starting with a pilot group of applications. Option C. Deploy broad network segment-based firewall rules across the entire infrastructure initially, with a plan to refine them to application-specific rules at a later stage. Option D. Implement vendor-provided default NSX firewall policies across all segments immediately to establish a baseline security posture and address specific application needs as they arise. The correct answer is B. Begin by analyzing traffic flows for critical applications, defining granular firewall rules based on observed communication patterns, and then deploying these policies iteratively, starting with a pilot group of applications. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network security, balancing the need for granular network segmentation and micro-segmentation with the operational overhead and potential for misconfiguration. The organization is experiencing a significant increase in sophisticated cyber threats, necessitating a more robust security posture. Implementing NSX micro-segmentation is a strategic imperative, but the project team is facing pressure to deliver quickly, without compromising the integrity or functionality of critical business applications. The challenge lies in identifying the most effective and compliant approach to policy creation and deployment that minimizes risk and maximizes security benefits within the defined regulatory framework. Correct approach analysis. The correct approach emphasizes a phased, application-centric methodology for NSX micro-segmentation policy creation. This involves starting with critical applications, forming thorough traffic analysis to understand legitimate communication flows, and then defining granular firewall rules based on this observed traffic. This aligns with best practices for network security and compliance by ensuring that security policies are directly tied to business needs and application dependencies. It minimizes the risk of inadvertently blocking legitimate traffic, which could disrupt operations and lead to compliance violations if critical services become unavailable. This method also allows for iterative refinement, reducing the complexity and potential for errors during initial deployment. The focus on observed traffic and least privilege principles directly supports the goal of reducing the attack surface, a core tenet of modern cybersecurity frameworks. Incorrect approaches analysis. One incorrect approach involves a broad, network segment-based policy deployment without deep application understanding. This is professionally challenging because it risks creating overly permissive or overly restrictive rules. Ethically and regulatorily, it fails to demonstrate due diligence in understanding application dependencies, potentially leading to service disruptions that could violate service-level agreements, SLAs, or even regulatory requirements for service availability. It also increases the attack surface by not enforcing micro-segmentation effectively at the application level. Another incorrect approach is to prioritize speed of deployment over accuracy by using overly broad, allow all rules initially, with the intention of refining them later. This is a significant regulatory and ethical failure. It directly contradicts the principle of least privilege and creates a wide-open attack vector, exposing the organization to immediate and severe risk. Such an approach demonstrates a disregard for security best practices and a failure to adequately protect sensitive data or critical infrastructure, which could have severe legal and financial repercussions. A third incorrect approach is to rely solely on vendor-provided default policies without customization. While defaults can offer a baseline, they are rarely tailored to the specific needs and risks of an individual organization. This approach fails to meet the professional obligation to conduct a thorough risk assessment and implement controls that are proportionate to the identified threats. Regulatorily, it may not satisfy requirements for demonstrating that security controls are effectively implemented and maintained, as it lacks the specificity and context required for a robust security posture. Professional reasoning. Professionals should adopt a structured, risk-based approach to NSX micro-segmentation. This involves 1. Understanding the business context and critical applications. 2. Conducting thorough traffic analysis using NSX tools or other network monitoring solutions. 3. Defining security policies based on the principle of least privilege, allowing only necessary communication flows. 4. Implementing policies in a phased manner, starting with less critical environments or specific applications. 5. Continuously monitoring, auditing, and refining policies based on observed traffic patterns and evolving threat landscapes. This methodical process ensures that security controls are effective, compliant, and aligned with business objectives, while minimizing operational disruption.